All right, now that we've taken a look at how the OBJ file stores data and how the MTL file works, what we need to do is, well, start creating our applications that can bring this data in. And then, in the end, show it. Now, we've got a lot of coding to do.
Lots and lots.
Lots and lots and lots. So we're going to break this up into several
fingers
different
hurt already.
videos. This video is going to focus on creating just the header. So it's going to be a model.h file is what we're going to be working on. Lots of code in it. Then from there, we're going to create the CPP file and start getting all of the code in place to get our objects loaded in. And then we'll have a video dealing with all of the code required to get our materials loaded in. And then finally, in the end,
we'll just kind of piece it all together.
Yeah, we'll piece it all together so that we can see some models in a viewport.
Right.
It's as simple as that. So there's a lot of things that's going to be going on here. We're dividing it up just to keep things focused and organized. So, Joel,
I mean, if we typed 800 lines of code in one video, everyone would die.
That's right. So let's go ahead and begin
by creating a new project.
That sounds fantastic.
So, file, new project, Win32 project, and because we are going to be using SDL in this one, we'll call this OBJ loader. Under application settings, we'll create an empty project. Press finish on that. All right, so we're going to include two files. Create two files, actually. A header file.
This is going to kind of be the heart. I mean, I know at the very end of this particular VTM, the goal is to show a model viewer with our models that we've brought in. But we'll be able to include these videos talking about creating the importer itself into other VTMs if necessary.
That's right.
In case we need to have people bringing in OBJ files.
Right, because they work as standalone.
That's right. So the heart of this is going to be our model.h and model.cpp.
That's right. So we have our model.h, and let's create our CPP file, our model.cpp.
All right, now for the most exciting thing in the world. We'll go right over to the header file and do the if not defined model_h, and if it's not defined, let's define it, and we'll end it off.
So exciting.
Oh, that I'm telling you, that is just mind-blowing.
Oh, yeah. And real quick, let me go ahead and go to my CPP file and just include it so I don't forget to do that later.
Look at you go.
Oh, yeah. I just did that because you weren't expecting it.
Now, in the header file, no, I wasn't. In the header file, basically, we have got a class.
Right. We have our class model.
Our model class. And then we've got several structs that are very important to how this whole thing operates. So let's go ahead and start out by blocking in our class real quick.
All right. So we have our class model. And let me just define the public section as well as the private section. And there's quite a few functions that we need.
And we'll come back to these. We're just slowly building the foundation. What are we missing, Joel? You can do it.
Semicolon.
Very good. Okay, so now what we need to do is go ahead and we'll just create the
structures.
Yeah, just the foundation of the structures, just so that we can talk about them real quick.
Right. So we have our struct material, which is our material structure. Let me just semicolon that in.
We've got a struct face.
So basically, our material holds all the different material attributes that we need for any particular material.
That's right.
Whether it's color, it's diffuse map, it's ambient map, etc. It's going to be held in our material.
We're going to have lots of different materials, or we could have lots of different materials brought in. We'll have lots of these.
And that's where the material file comes in. That's where everything stored in the MTL file is going to be stored.
That's right.
And then we have our face, which holds all the different vertices associated with a particular face.
With a face.
Right.
That's right.
So that's the normals, it's UVs, it's vertices, etc.
That's right. Now we have a struct group object.
Group object. And basically inside of here, let me put in my semicolon, each group object, we could have multiple in a particular OBJ file, and basically this holds a list of all faces that we're going to be working with.
That's right. And each face is associated with a particular material.
Right. And inside of here, this is going to have a pointer to a particular material.
There you go. So you're starting to see, hopefully by now, how all of this ties together. Because all these parts are closely related.
Very much so.
Okay, so now let's go ahead and just start with the face struct. And we'll go ahead and fill in all of the goodness.
All right. So we'll go do the face, and then we'll do the material.
Right.
So we'll start out with our vector3, and this is, remember, the class that we've created in the past.
That's right.
And it's going to be a pointer to a pointer of vertices. In other words, an array of pointer vertices. And we need to know
how many
there are. And basically, inside of our model class, we're going to have a function called drawFace that goes through this particular face and draws all of the vertices for it. And then we're also going to need, just copy this.
Yeah,
it's very similar.
Because we're going to need to do the same thing with the normals and with the UVWs.
Yeah, so num normals and the UVWs. And we have our num UVWs.
And again, it's the exact same thing. We need to know how many UVWs we have, how many normals we have, and then, of course, we need to point to them.
Right, because these are just pointers. They don't actually store the number of vertices that we have, so that's why we need a separate integer for that.
That's right.
And then we also need a material, because remember we said that each face has a material associated with it. So a material pointer, and just for good measure, I'm throwing in two other vectors. 2 vector 3s. One's called face center, which stores the center of this particular face.
Which is something that we're going to calculate ourselves.
Right, when we're loading it in.
Right.
And I found this to be really useful if you're creating some projects and it becomes useful for you.
Mm-hmm.
Also, notice I have a face normal as well. And basically, your normals can be pointing in different directions for each vertex. The face normal is the overall face's normal, the center normal, if you will. And that can become helpful in certain projects as well. So we have quite a few pointers here. We have our vertices, normals, UVWs, material.
Yeah,
let's go ahead and initialize. Yeah.
Right.
So every time we create a new one, we'll call this constructor, if you will, and we'll initialize the vertices to null, semicolon. Our normals equal to null, and our UVWs equal to null. And our material is going to equal null as well.
And that's pretty much it.
Yeah, that's all that we need for our face.
So now that we know we have a face that has a material associated with it, let's go ahead and jump up to material.
And block this one in.
That's right.
So this one's quite long, actually, because there's a lot of different things that a material has associated with it.
Sure.
It's constant ambience, it's diffuse, it's specularity, and then a whole bunch of textures that are associated with it as well.
Oh, you didn't say the last one. You can do it.
The name?
Go ahead.
Emissivity. Emissivity. So, I'm close.
You're close. Good enough.
So basically,
the KE.
The KE, exactly. So we have our KA, which is the ambience.
That's right.
And this is going to have four array value because we're going to have our R, G, B, and alpha.
Right.
And then let me copy this 4 times, not 3 times.
And then just KD, KS, and KE.
Right. This is kind of just to stay with convention. I mean, I could type it all out as ambient, but this just simplifies it.
Sure. Now we've got 3 floats. We need to define our shininess, our alpha, and our illumination.
Right.
Nice.
So now we have all the different textures that can be associated with a particular material.
And there's quite a few.
Yeah, there is quite a few.
We've got an ambient map, a diffuse map, a specular map, an emission map, shininess map, obviously the good old transparency map, and let's not forget
the
bump map.
Right, and these are just things that can be thrown into an OBJ file, which will allow us to, do things like add a bump map to our material or something like that. In this one, we're only going to, at the very end, we're only really supporting the diffuse map. But if you want to add extra functionality in so that every single one of these maps is supported, you can simply modify the draw code.
Right.
So inside of here, we're going to do our texture, and this is utilizing the texture class that we created.
Map, go and copy and paste.
Something like that. So we have our diffuse map, our specular map, our emission map,
and our shininess map.
I spelled that wrong.
You sure did.
That's okay. There we go. What else do we have?
We have our transparency map and our bump map.
Wow, I did type. Wow, that's awesome. So we have our bump map. And finally, we have a name for this particular material. So we'll do a string name. And right here, we just utilized the string class. So let me just go up here real quick. And
look at you go.
Yeah, I just don't want to forget. So using std string, just to make it self-contained.
Sure.
So at this point, we have all the variables we need for our material. But again, like with the face, let's go ahead and initialize all of them, because we have a lot of pointers here, and we want to make sure we can test whether or not they exist by comparing it with null.
That's right.
So let me set all of these diffuse maps, to null. So let me just add a null to the end. I'll delete the first part in just a second. Just kind of paste all of these in. Diffuse map. No.
Faster. You can do it, Joel.
I know,
I'm trying. Yeah, look at that go.
Yep.
This boy can type.
There we go.
We've just sped the video up. You guys don't know it. Not really.
So here we have our map set over to null. And let's go ahead and give these arrays some default values as well. So let me create a few arrays inside of here to store our default colors. So let me set the default ambient to a black. And let me go ahead and copy and paste this for our diffuse, specular, and emission.
Yep.
So default diffuse, default specular, and default emission. And then for our diffuse, we'll set the default color to white. And then the rest we'll just leave it black as well. So just something that we can default all of our things to. And then at this point, we need to actually copy them into our values, excuse me. So we're going to do a mem copy. Copy them into our other variables. Exactly, thank you. I was at a loss of words. So our default ambient and size of float multiplied by 4. And then we'll just copy this 3 times and put our diffuse map in, our specular map, and our emission map. And change this over to KD, KS, and KE. So that's our material. Okay, very cool. So at this point, we have our material. We have our face. So now we need to go ahead and get the necessary stuff in for the group object. And again, this is just a list of faces. That's right. Essentially, that's all it really is. Well, that's all an object really is. Yeah. So a list of faces, and we'll just say faces here. And then we also do have an object name and a group name, though, which object, what his object name is and what group he's associated with. So string, group name, and that's it. That's all we have. I told you it was simple. Yeah, that was very simple. Okay, so now we've got all of the pieces for the geometry and materials that we've brought in, if you want to look at it that way. Yeah. Let's go ahead and start working on our class, because this is the engine to the whole thing, if you will. Right, I'm going to do something a little interesting here. I'm going to first block out some of the variables that we need inside of here. Cool. So things that we need inside of our model. Well, we're going to need a list of all our group objects. So I'm going to do a list, a vector group object, and since we're using vector, well, actually we use it here as well. I'm going to go back all the way to the top and go ahead and include this. So include vector using std vector. So out here, we're just going to call this objects. So this is a vector list of all our objects. Right. So now we need to store all of our vertices. Right. Basically, if I, in 1 second, after I type this out, I'm going to go back up to my face and explain a little bit of something that's kind of important. So we have our normals, and we have our UVWs. So basically, these 3 right here are going to store all the vertices, all the normals, and all the UVWs used inside of our OBJ file. And if we go back up to our face here, these are pointers to each of those vertices. So these are pointers to a bunch of pointers. So basically, what we store in our model class stores everything, so we can clean it up easily in our inside of our destructor, or if we need to load a new file, for example. Yeah, very nice. So we also need a list of all our materials. Right. So let's create a vector list of materials. Now we go ahead and do the bounding box. So we've got bounding points. Right. So basically, this allows us to, and again, this is something that I find very useful. If you need to do a bounding box for our model. Right. And since we have 8 vertices for our bounding box, and this cube. Yeah, exactly. And what this allows us to do is do things like bounding box collision if we needed to. And this is done right at the load time. So we load in the model, fill in this value, and then the programmer can go in and just check our bounding points very, very simply. And then we also need the radius of our model. So this basically takes the extents and calculates a radius for our model. And then center. Vector 3, thank you. Center for our model, and this again is calculated at the end of our load as well. And then we're going to do a Boolean that basically says, has the object successfully loaded? Because the user, at first this is obviously going to be false, and then if the load object succeeds, we're going to set this to true. And this just allows us to, in our draw code, check this and say, if we're not loaded, just exit out. Now, of course, a very big thing in regards to drawing things through OpenGL, we're going to go ahead and get our display list set up. Right, so we'll create an unsigned int, and we'll just call this display list. And basically the way this is going to work is when we draw our model, we're going to first, on the first pass, create a display, compile a display list, exactly. And then on every succeeding call to it, we'll just call the display list, exactly. Speed things up nicely. Actually, it can have a huge increase in speed because of that. So there we have our file name. So with that, that's all of the variables we need for our model class. Let's go ahead and block in the function calls that we're going to need. And of course, we're going to need our model, our constructor, and we're going to pass the file name. And let's see, what else do we need? We need a destructor, so we'll create our model destructor. Okay. And then there's quite a few things.
Now we've got a bunch of different things. The bottom line is we need to be able to draw our model.
Right.
And then which is going to draw our object, which is going to turn around and then draw the faces.
Exactly.
So there's 3 different functions right there we need.
So let's do our draw model, just to kind of put this in order.
In order, yeah, which is going to end up calling the draw object.
And basically our draw model is going to call draw object twice, basically with transparency and without transparency. And this allows our model to be drawn correctly with transparency without having to do a depth sort.
Right.
So draw object, and it's simply going to pass transparency, and we'll default this to false. And then finally we're going to do our draw face.
Because that ends up getting called by draw object.
Yep. And we're simply going to pass it a reference to our face.
Mm-hmm.
Did I spell that wrong? Yes, I did. Yes. Sweet. So with that, let's see.
Now we need the ability to delete objects.
Right. So we need to delete out our objects. So we'll do a delete objects void. So this is going to be called by the destructor, and anytime we load a new object, we'll delete everything that's already there.
That's right. Now, of course, we need to be able to do, like you just said, and load
objects. Let's see what this is going to be called.
The load object.
Actually, we'll return a bool for this.
Yeah, if it did or didn't.
Succeed.
And
pass our file name.
The file name, obviously.
Yeah.
And then we need to be able to load our materials.
Right, and basically load object is going to call load materials and pass it the name of our MTL file.
That's right.
So, string file
You guys
name.
can see how this is being broke up in such a way that it's very manageable and easy to work with.
Yeah, definitely. And then, of course, we have all our get radius, our center, our radius,
a couple extra things
accessory
that
functions
we find quite helpful.
Yes, very much so. So we'll do a get radius, and we'll do a get center. And finally, we'll do a get path, which returns the file that we're currently loaded, the whole file name. And let me make sure, I did include it on the bottom. I totally forgot about doing that. Wow. So with that, I think that's everything we need for this section right here. Of course, I think I do need to include my texture.h.
Right. There's actually several things that need to be included.
Texture.h and vector3.h. And we also are going to need to use some string stream and various other things like that. However, I'm going to add those in once we start working with the actual loading.
Okay. So
that you can actually see exactly which function calls are going to need which header files. Otherwise, it just is like magic, and I don't want that.
So that's pretty much it. This gets 98% of the header file complete.
Yep.
So with that, we're ready to go ahead and move over and start working on the CPP file. So that's going to wrap up this video. Thanks a lot.